Hello and welcome to Intermediate Algebra Unit 6, Lesson 5, Part 2 of 2. We will now look at using quadratic equations to solve applications. So our lesson objective is to solve application problems that are modeled as quadratic equations. Now this might sound a little bit like it's written in code. Application problems just mean problems you're presented with in words or a situation. And then what happens is you're not just given the equation to solve. You have to use the situation to create the equation that needs to be solved and then solve it. So it's one step beyond just solving equations. You need all those solving equation skills to end up getting an answer to the problem, but creating the model is a step that has to be done first. So we have to translate the problem situation into an equation, and then we solve the equation. Then we have to go back and check to see if the solution makes sense or satisfies the conditions of the original problem. Examples of where a solution to an equation might not make sense is if you're asked to find a width and you get two answers and one of them's negative. Well, the width of something won't be negative, so you can ignore the negative answer and only choose the positive answer. That's just one example of making sure that the problem is answered with an answer that makes sense. So we're going to look at two classic types of application problems in this video. One is what I call a number problem. You're given a statement about some numbers or a number in this case, and asked to find what the number is. So the square of a number minus the number is 20. Find the number. So you don't have to keep writing the words the number again. So we're going to let x represent whatever this number is. And it's helpful to write that down. Let x be the number. Let x equal the number. So then you go back and translate this into an algebra. The square of a number, well, now instead of a number, we're going to use x. The square of x becomes x squared, x with an exponent of 2, minus the number, well, remember the number is x, so x squared minus x is the number, is 20. This word is almost always becomes an equal sign in these application problems. So you replace is with equals and you get 20. So the square of a number minus the number equals 20. Now this is a quadratic equation we know how to solve. We have to set one side to 0 first by adding or subtracting. We need to subtract 20 from both sides in this case. So we're going to be solving the equation x squared minus x minus 20 equals 0. And the method we know so far for solving this is by factoring. We don't know any other methods yet, but you will see more later in the course. So this factors to x minus 5 times x plus 4 equals 0. So either x is 5 or x is negative 4. Turns out both of those are good answers here. They both make this equation true. And it didn't say the number had to be positive or had to be negative. It just said a number. And it said find the number, but there's actually two numbers. If this problem had said the square of some positive number minus the number is 20, then we would only take the 5. But in this case, they're both good answers. 5 squared is 25, minus 5 is 20. Negative 4 squared, now be careful if you do this in your calculator, you have to put the negative 4 in parentheses. You should get positive 16. Whenever you square a number, you're multiplying it by itself, so the sign of the two things you're multiplying together will be the same, so you should get a positive result. Negative 4 times negative 4 is positive 16, and then I subtract a negative 4, means I add 4, 16 plus 4 is 20, so those both work. So here's one for you to try. It's very similar. It uses similar words. You have to remember that twice means you multiply by 2. Take a look at this, stop the video on this slide, try to solve it, and then come back. Alright, you're back. The square of a number minus twice the number is 48. Well, the is going to be an equal sign. We know that. We need to find the number. X is the number. I'm going to use x to represent the number. X squared minus twice x is 2x. equals 48. I have to move the 48 by subtracting 48 from both sides. This does factor, and I get 8 is one possibility and negative 6 is the other. Again, I wasn't told it's a negative number, it's a positive number. It's not a problem where I'm taking measurements that can't be negative, so both of these seem to work in the equation. 8 squared is 64. 2 times 8 is 16. 64 minus 16 is 48. Negative 6 squared is positive 36. Minus 2 times the negative 6. 2 times the negative 6 will be a negative 12. You're subtracting a negative 12, so you get 36 plus 12. That's 48. There are two answers, and they are 8 and negative 6. So here's our second kind of classic type of quadratic application. And this students tend to have trouble with because it deals a little more with spatial reasoning and you can't see what's going on. You can solve this by drawing the picture. The picture was not given with the example. All the problem would be these three sentences here at the top. So the problem statement is the width of a rectangle is 2 meters less than the length. The area is 15 square meters. Find the dimensions of the rectangle. That's all you're told. I find it very helpful to draw a rectangle and then label the sides with either L or W or whatever makes sense for the problem. In this case, I decide to label the length L because nothing is done to the length in the problem. The width is found by using the length, so the length can just be L, and then I see the width is 2 meters less than the length. So I don't know what the length is, I'll call it L. The width must be L minus 2. I label my sides. Now, I am told the area of the rectangle. Area is length times width. So I'm going to multiply L times L minus 2, and I should get 15. So you have to remember that area is length times width. You have to know that. That's why sometimes these problems are harder too. So L times L minus 2 equals 15 represents the area of this rectangle being equal to 15. When I multiply out the left side, I get L squared minus 2L equals 15, but I have to make the right side or one side 0, so I subtract 15 from both sides and get L squared minus 2L minus 15 equals 0. This factors, I get answers of 5 or negative 3, but this is a problem with dimensions. The negative 3 makes no sense, so the length is 5. I take the positive answer, and if the length is 5, I can go back to my picture and see that the width needs to be 5 minus 2, or 3. So the length is 5, the width is 3, 5 times 3 is 15, that is correct. So this one is very similar. I'd like you to try this one. Draw a picture, label it, and try the problem just as I did in the last example. Stop the video now, and try that, and come back and see the answer. Okay, so I hope that went well. I hope you didn't just get stuck. So again, we're told the width is less than the length, so let length be L and the width is L minus 5. If I was told the length is less than the width, I might have labeled W and then label the other side W plus or minus. But you're not told anything about the length, but you are told the width is related to the length, so label L, length is L, and then make the width, whatever you're told, 5 centimeters less than L. So I do L times L minus 5 for the area. That's 24. I didn't draw the picture here, but it's helpful if you had drawn a picture. When I multiply the left side out, I get L squared minus 5L, and then I have to move the 24 to get this to be 0. I have to subtract 24 from both sides, and then I can factor. This factors to L minus 8 times L plus 3. So the answers are 8 and negative 3. I can't choose the negative 3 because length is positive always. So 8 is the answer, but then when I do 8 minus 5, I do get positive 3. So it is related, but you ignore this for the length. It's an answer that makes no sense if it's negative. If you're talking about geometry and measurement, when you're solving a problem that just says a number, negative numbers are fine. Alright, well, I hope this helped you sort out a couple of the things you'll be encountering in your homework and in the rest of the course, and email me if you have questions. Thank you for watching.